The ultimate criterion to evaluate software modularity is its ability to adapt to changing environments. Truly independent modules can evolve independently, adapt to new requirements, and even be replaced with better versions without affecting other parts of the system. DV8 can evaluate the quality of a modular structure by taking advantage of the evolution history of the system. In addition to displaying structural dependencies between files, DV8 can display the number of code changes, that is, the number of commits where both files were modified, as recorded in the project's revision history. The number 10 in the grid indicates that these two files have been modified together in 10 different commits. Research shows that if two files are often modified together, they usually have explicit or implicit dependencies. The greater number of code changes, the stronger the dependency between them. We call this relationship evolutionary coupling. A set of files that exhibit evolutionary coupling forms a de facto evolutionary module. If the input of DV8 is a Git repository, the user can choose to analyze the commit history within a specified time range. After the analysis is successful, DV8 will generate a structural DSM and a history DSM, in which the number in the cell indicates the number of times the two files were submitted together. DV8 also generates a merged DSM containing both the structure and history dependencies. The DSM that you see now is extracted from the Git repository for Apache Flume. A cell may contain both structural and evolutionary coupling information. The user can hover the mouse over a cell to view the detailed information. You can also right-click a cell to display detailed dependency information in a pop-up window. And you can navigate to the source code or revision history to check the source of the dependency, or the commit record. If the user selects the menu matrix, toggle modularity violations, the cells with numbers in red font indicate that there is no structural dependency between the packages or files, and the numbers show how many times they have been modified together. This situation usually indicates that there is an implicit dependency between the files or packages. Users can use the matrix cell options menu to configure the threshold above which evolution coupling will be displayed. For example, if the user enters a threshold of 10, DV8 will only display the number of code changes greater than or equal to 10. The user would set this threshold based on the status of the project. For projects with a short evolution history, the user may choose a smaller threshold, such as 3 or 5. For projects with a relatively long evolutionary history, setting a larger threshold can filter out accidental code changes that do not reflect implicit dependencies. In this way, a user can check which packages or files have no structural dependencies but often change together, forming a problematic evolutionary module. DV8 can detect several anti-patterns based on the integration of structural and evolutionary coupling. Unstable interface, which assesses the quality of design rules with respect to evolution history. High-quality design rules should remain stable and not often change with other files. Unstable design rules often change together with their dependents, showing strong evolutionary coupling. Crossing, which identifies files with both high fan-in and high fan-out, and frequent changes with other files. Such problematic files are usually God classes, blobs, large classes or files containing spaghetti code. Modularity violation, detecting file groups that do not have structural dependencies, but often change together. We will show how to use DV8 to detect these anti-patterns in another video. We have shown that, using DV8, the user can observe two different types of dependencies at the same time, structural dependencies and evolutionary coupling. As a general dependency model, a DSM can express any dependencies between services, configuration dependencies between components, or dependencies between test suites and source files, and even dependencies between programmers. DV8 provides a standard representation, so that multiple types of dependencies can be integrated and analyzed together.